Okay, this first lesson in our trigonometry course called 4.1 Angles and Their Measure. We'll talk about angles and specifically two ways that we can measure angles. One you'll be familiar with. One is called degrees. You've been measuring angles in degrees for quite a while. And then the other one is called radians. Radians is the new one, although you'll kind of find when we talk about arc length and circumference of a circle that you've actually been calculating angles with radians already. You just probably didn't know it up until today. Okay, so let's begin with degree measurement. Degree measurement, it's the one you're most familiar with. You should be from your years in math up to now. You're familiar with definitions of acute angles, obtuse angles, right angles, and all those definitions center on how many degrees the angle measures. A degree is a unit of angular measurement. It's a unit of angular measurement equal to 1/360th of a circle. In other words, there are 360 degrees in one revolution of a circle. Okay, so no real new information there. We probably know that already. Now, we'll kind of extend on that a little bit and we'll talk about this what we call DMS form of angular measurement. It's using degrees. It stands for degree, minute, seconds. It's how we measure like fractional parts of degrees. Not every angle is going to be an integral value like 20 degrees. What if the angle was 20.2 degrees? This would give us a way to represent that, kind of tying into the circular idea of angle measurement. So let's look at a couple examples of that. Okay, let's begin with converting from DMS form, degree, minute, second, to decimal form. So here this reads 23 degrees 12 minutes. The mark here meaning minutes. So to convert into decimal form, we have to know how many or what fractional part of 1 hour is 12 minutes. Well, 12 minutes, there are 60 minutes in an hour. 12 divided by 60 is 0.2. So 23 degrees 12 minutes is the same as 23.2 degrees. Okay, this one over here, 118 degrees 44 minutes. We know what that is. And then this part here is 15 seconds. Okay, the double mark there meaning seconds. So how would I do this? I need, we could just set up a math sentence to work this out. See, it's 118 degrees plus 44 minutes. 44 minutes out of 60 minutes make up an hour, plus 15 seconds. 15 seconds out of, I need to think how many seconds make up an hour, and that would be 60 times 60, 60 seconds in a minute, 60 minutes in an hour, so 3,600. So if we work this out, and a calculator would help, I have 118 plus 44 divided by 60 plus 15 divided by 3,600. On the calculator I have 118.737 5 degrees. Okay, next let's do some examples going from decimal form to DMS form, just the reverse of what we were doing. And how would we do that? So I start with 21.2 degrees. Now we just saw 0.2 in the last example, so we know that it's 12 minutes, but how do we get 12 minutes? I'm going to take the decimal part of this. I'm going to take the 0.2 and multiply it times 60. There's 60 minutes in an hour. This will tell me how many minutes proportionally is 0.2 of an hour. That would be 12 minutes. So this is 21 degrees, 12 minutes. Similarly, let's try this one. It's the same kind of thing. I need to know what part of an hour, how many minutes and seconds possibly is 0.32. So 0.32 times 60 is equal to 19.2. Okay, so I've got 0.32 is equal to 19.2 minutes. Well, there's a fractional part of the minutes here, and I want to know how many seconds is that. So I'm going to take that 0.2 times it by 60. There's 60 seconds in a minute, and that gives me 12 seconds. So I'll write the whole thing as 118 degrees, 19 minutes, 12 seconds. Okay, next let's talk about radian measurement. This is probably the form of angular measurement that will be new to you. So a radian, let's maybe draw it first. May be a little bit easier if we draw it first. And let's try and draw a circle. Okay. Let's draw. There's my radius. I'm going to draw another radius here. And I've got an angle, we'll call it theta, inside there. Okay, so what is a radian? A radian is a unit of measure in which the central angle of the circle, this angle right here, intercepts an arc length, this arc on the outside of the circle is equal to the radius. So it's a unit of angular measurement measure in which I'll say the central angle of a circle intercepts an arc of equal length to the radius. So there is 1 radian. Okay, so the most obvious question following that definition is, we know there are 360 degrees in one full turn of a circle, 360 degrees all the way around. Question is, how many radians are there in one full revolution of a circle? So let's kind of take this circle, it's better than the one I drew on the last slide, and let's kind of diagram in 1 radian again. This is just kind of approximate. So here I've got my radius length. Here's my radius length, here's my angle, which is equal to 1 of these radians, and here I've got this length on the arc that's the same as the radius. So the question is, how many of these, think of them as like pie pieces or slices of pizza, how many of these slices would fit in this circle? Okay, well, you could attempt to draw it out if you wanted to. You could attempt to say, here's another one, maybe like that. There's another one of these radius lengths, maybe. There's another one. You can kind of keep going like this and just kind of eyeballing it, I guess. Maybe there's another one. Let's see, maybe there's another one. Maybe there's another one. It looks like there are, let's say, a little more than 6 radians. A little more. How much more? But we can do better than that. Let's think, maybe, and answering the question, how many of these are there in one turn of a circle? How many of these are there? How many radius lengths are there in one turn of the circle? And we do have an answer for that already. We know from geometry what the circumference of a circle is. The circumference formula is equal to pi times the diameter, or better for us today, circumference is equal to 2 pi times the radius. Well, circumference is just arc length, and I want to know what the length of this arc is. The length of this arc is 2 pi radii length. 2 pi times whatever the radius is. There's 2 pi of these radius lengths around the circle. In other words, one circle has 2 pi radians. 2 pi as a decimal is about 6.28. There are 6.28 radius lengths going around the outside of this circle. But exactly, there are 2 pi radians in one revolution. Okay, so knowing that there are 360 degrees in a circle, and there are also 2 pi radians in a circle, we know that 360 degrees is equivalent to 2 pi radians. They're one and the same, just different units of measure. And just like 12 inches is equal to 1 foot. They are the same, different units of measure. Well, we can get some easy conversions here. 180 degrees, half a circle, should be equal to half a circle. Half of 2 pi is pi. So 180 degrees is the same as pi radians. Well, what about 90 degrees? 90 degrees is half of the half, or 1/4 of the full. Well, if we take half of the half, or 1/4 of the full, 90 degrees is the same as half pi, or pi over 2 radians. And so we can pretty easily get some of these conversions when we're just taking halves of the whole and that sort of thing. But what about these? How would we come up with 250 degrees in radians? Or 136 or 580? We need a way to convert any degree that we have into radians, and quite frankly we need a way to convert any radians we have into degrees.